Hi everyone. In this session, we will see the radiation patterns of an antenna. Uh, so what is radiation pattern? Basically, if an antenna is a radiating element which is going to transmit your electromagnetic waves into the free space, when it is transmit the electromagnetic signal into the free space, we trace what is the field strength around an antenna. So the graphical plot of that field strength around an antenna is the visualization of the energy. So that will give you the radiation pattern. So now from the radiation pattern, you can identify where the signal is maximum and where the signal is minimum, like that. So that is will be very helpful to design an antenna for any specific applications. So when you plot the radiation pattern around an antenna, there are two possibilities. Either you can plot it as a 2D polar plot, or else you can plot it as a 3D spherical plots. And from this antenna radiation pattern, so you can calculate what is the directivity of an antenna, and what is the gain, and what is the efficiency of an antenna, based on which you can decide where it can be applied or how it has to be modified in order to utilize for an application. So this is the radiation pattern, exact radiation pattern that is being represented in terms of a polar plot. So you can see the color variations which indicates the gain levels. So it is minima, maxima, and the mid levels. So what is lobes means the antenna radiation pattern antenna, where the energy concentration is being represented by means of a graphical plot. We call it as the lobes. So these lobes we classify into four types basically. So first one is the main lobe, which means that it is a primary plot. First one is the main lobe. So this is the primary direction. This will indicate the primary direction along which the maximum radiation has been transmitted. So other than the main lobe, all other lobes we call it as a minor lobe. But still we name the minor lobes with specifically as a side lobes and the back lobes. So side lobes is the undesired lobe which is very adjacent to that of the main lobe or the major lobe. We call it as a side lobes. And the other lobes, which is all other lobes other than the major lobe, we call it as a minor lobes. And the one which is the lobe which is exactly 180-degree opposite to that of the major lobe, we call it as a minor lobes. So now when you see the diagram, you can see there is a radiation pattern being plotted, and the size of the lobes might be varying. So along the major axis it is of wide enough, and along on in and the my side lobes and the minor lobes we have a very narrow beam structure. In between the side lobe and the major lobe, you can see there is no radiation pattern is being measured. So these points which occurs between the lobes, we call it as the null points. So it means that at that point the radiation might be minimal or else completely zero. So this is the structure of a main lobe. So you can see the maximum power. So it indicates the maximum power radiations along the axis, whichever be the direction of an antenna. Along this axis, the radiation power can be decided. So this radiation pattern actually indicates the radiation pattern of a directional antenna. So we have a classification of antennas like a directional antenna, omnidirectional antenna, and isotropic antenna. So if it is going to be directional antenna, the radiation pattern will be maximum in only one particular directions. Whereas in the case of the omnidirectional antenna, so we have a radiation around the antenna in all the directions, which means that the radiation can be experienced around 360-degree. But the gain of an antenna cannot remains the same around the antenna. That is around the 360-degree. So whereas the isotropic antenna, it is not physically realizable. So it is difficult to do like that. So it radiates the electromagnetic waves around an antenna in all the 360-degree directions with the same magnitude. So that is highly impossible. It's an hypothetical condition, but still we have that antenna as a reference antenna. So now here you can see this is the major lobe, and this indicates the primary direction of transmission of a signal or the reception of the signal. So from this direction, you can identify what is the directivity and the beam width. So which is the angular width at the half power. You can find out where you have the angular half power beam width or a first null like that. You can check that also. So this is the focused transmission. The parabolic dish antenna main lobe is precisely directed towards its target for efficient communications. So whichever be the direction you want to transmit the signal, so by that time you can expect the major lobe towards that direction, and the minor lobes will be the undesirable lobes that is adjacent to it. So in this, you can see the this is our major lobe as we have seen already, and the all other lobes we call it as the minor lobes. So the lobes which is marked in green color are the minor lobes. With the lobes which is very adjacent to the major lobe, we call it as a side lobe, and the lobe which is exactly 180-degree opposite to it, we call it as a back lobe. So the radiation here is observed in the two-dimensional plane, where the plane can be divided into azimuthal plane and the elevation plane. If the rotation of an antenna is with respect to the horizontal region or the horizontal plane, in that case, that plane is termed as the azimuthal plane. Suppose if the rotation of an antenna is from the ground level to 90-degree or 270-degree or 180-degree in a vertical direction, or the vertical direction is or along the z axis with respect to that diagram, we call it as an elevation plane. So now you can see this is our radiation pattern for the major lobes. In the radiation pattern of the major lobe, beam width you can identify by taking a 3 dB line with respect to the maximum point, and that angle projected towards the center of the lobe from the minimum point or the 3 dB point will give you the half power beam width. So that will be essential for designing an antenna. So now what is your side lobes? So like side lobes are the adjacent to the major lobe, and it denotes the radiation in an undesired direction. So if you are radiating a signal in the undesired direction, so that may interfere with the other systems, and it will may reduce the overall efficiency of an antenna. So the efficiency of an along with the losing of efficiency of an antenna. So here the low power will also get wasted. So actually my entire signal has to be transmitted only along the z-axis, but still there some of the radiations is being observed other than the z-axis. So which is being marked in the green color. So my power is being wasted in transmitting the signal as a side lobes. So this has to be avoided. So this is an undesirable radiation lobes with respect to an antenna. So the relative levels of a side lobes can be calculated with respect to the major lobe. So that will decide whether the side lobe will very harmful or it is a minimum. It is in the minimal level. So suppose if I'm having a 30 dB maxima for the major lobe, and if I have only 1 dB with respect to the side lobes. So 1 is to 30 we calculate, it will be around the 0.3 percentage only. So that will not make much impact on the radiation pattern of an antenna. So the third part of your radiation pattern is the back lobe, you can see. So the light blue color lobe, which is exactly 180-degree opposite to that of the major lobe, we call it as a back lobe. So this is also a minor lobe. As the position is exactly opposite to the major lobe, we call this as the back lobe. So it represents the radiation that is being emitted in the backward direction. So which is not at all desirable. So it is a wastage of energy. So it has to be curtailed in order to transmit the signal effectively. So another important point is as it is being transmitted in the undesired direction, there is a likely chance it can interfere with the nearby radiations also. So that has to be taken into account, and back lobe can reveal the antenna location, and security vulnerability is also possible because of this back lobe radiation. So this back lobe has to be reduced considerably in order to provide a high security for data transmission, which is of with higher importance. So these are the practical implications of the lobes. So the main lobe focus is towards the intended target. So which is my desired target? In that target, it has to be transmitted, and the maximum radiation should be conveyed information effectively with a clarity and reliability. So if you are having a side lobe issues, that may lead to the false signal understanding, and undesirable interferences may cause because of the side lobes, and there will be reduction in the signal to noise ratio, and the overall signal quality may also get reduced because of the presence of the side lobes. So that has to be taken into consideration. So back lobe risk, as we have discussed already, so back lobe, there is a likely chance of security threat, and this has to be avoided, and eavesdropping opportunities has to be overcome by means of suppressing the back lobes with respect to an antenna radiation pattern. So the main goal of a designer who designs the antenna is to maximize the main lobe gain and to reduce the side lobes as well as the back lobe radiation strength. So to design an antenna for any specific application, these 4 points has to be considered by an antenna designer. So how to control the lobes? So first one is the antenna array and the beamforming. So if I'm not getting a sufficient strength from one single antenna, so by that time I can go for an array of antenna by radiating towards the same directions. So there will be the strength will of an antenna will get intensified, and it will improve the signal strength in the receiver side. The other one is, suppose if I am not focusing the antenna radiation towards the desired direction, so we can go for a beam forming. So it means that it can focus the electronically steered the beam radiation towards the desired direction, so that the entire desired signal can reach the receiver without any loss. And the second part is the physical design elements. So there are possibilities you can add some reflectors and directors along with the top of a transmitting antenna. So if my antenna, which is my radiating element, is going to transmit a signal, all the signal can be focused towards the feeding point by means of appending one reflector to the antenna. The same way, the signals can be received by a receiver by directing all the electromagnetic signals towards the feed point. So that is also possible with respect to the director. And some absorbers also can be attached to it in order to suppress the noise. So the before implementing the antenna into a practical part, so we can simulate an antenna, we can find it out whether the antenna resonate at particular frequency, and the radiation pattern is as per our requirement, whether the side lobes are being suppressed. All these can be verified before implementing the antenna as a hardware. For that, we have many softwares available in order to check the radiation pattern of an antenna. So, as a summary of the presentation, we focused on the performance and the directivity of the radiation pattern of an antenna, which will basically define the performance of an antenna and the desired direction, strength, and what is the undesirable quality of the side lobes present in the radiation pattern. So for visualizing and analyzing the lobes, the engineers or whoever designed the antenna can go for a simulation in the initial stage, find out what is the exact length of an antenna which can radiate the signal in the maximum part in the desired direction and suppress the undesired side lobes. So here always we try to find out what is the energy transmitted with respect to the main lobes and what are the energy transmitted with respect to the side and the back lobes. Based on the proportions, we decide whether the side lobes is very harmful or it is okay. You can proceed with the existing system. The quality and the efficiency of an antenna can be enhanced by focusing the entire energy that is being fed to the antenna towards a desired direction, and the directivity of the antenna can be enhanced. So from the radiation pattern you can now you can understand what is the main lobe, what is the side lobes, and what is the impact of the side lobes in the radiation pattern, and how it has to be designed in order to provide a maximum directivity in the desired signal. So thank you all.